The Big Bang is not where time began. There was something before it, another universe that ended so our universe could start. I know this sounds impossible because we're told the Big Bang created time itself, that asking what came before is like asking what's north of the North Pole. But the mathematics tells a different story, and the evidence is written in the cosmic microwave background radiation filling space right now. Let me explain why the universe is far older and stranger than you've been taught. The standard story goes like this. 13.8 billion years ago, the universe began in an infinitely hot, infinitely dense state called a singularity. Space and time themselves emerged from this singularity. Everything that exists, all matter and energy and the laws of physics, came into being in that moment. Before the Big Bang there was no before because time didn't exist yet. This story has tremendous observational support. We see galaxies moving apart as space expands. We detect the cosmic microwave background, the afterglow of the hot early universe. We measure the abundances of light elements formed in the first minutes. All of this matches predictions from Big Bang cosmology beautifully, but there's a problem with treating the Big Bang as the absolute beginning. The problem is the singularity itself. At a singularity, density becomes infinite. Temperature becomes infinite. The equations of general relativity break down completely. We cannot describe what happens at the singularity because our physics fails. Singularities are where our theories stop working. They're signs that we're missing something, that our description is incomplete. Treating the singularity as a physical beginning is giving up on understanding rather than pushing through to deeper truth. I've spent decades thinking about what really happens at the Big Bang, and I've come to a radical conclusion. The Big Bang was not a beginning. It was a transition from a previous state of the universe. What we call the beginning of time was actually a boundary between two cosmic epochs. This idea is called Conformal Cyclic Cosmology, or CCC. It proposes that the universe goes through infinite cycles. Each cycle begins with what looks like a Big Bang and ends in a state of infinite expansion and dilution. But that ending for one cycle becomes the beginning for the next. Let me explain how this works. The universe is currently expanding, and that expansion is accelerating due to dark energy. Billions of years from now, this acceleration will carry galaxies beyond our cosmic horizon. Eventually, all the stars will burn out. Black holes will form and then slowly evaporate through Hawking radiation. After an unimaginably long time, perhaps 10 to the power of 100 years or more, the universe will contain nothing but extremely dilute radiation spreading through expanding space. This sounds like an ending. Everything decays, everything disperses. The universe approaches a state of maximum entropy and minimum structure. Heat death, the final fade to black. But here's the key insight. In such a universe containing only massless radiation and no matter, the concept of time becomes ambiguous. Photons don't experience time. From a photon's perspective, the journey from emission to absorption takes zero time regardless of how far it travels. If the universe eventually contains only radiation, if all massive particles have decayed away, then there's no way to define a clock. The distinction between 1,000,000,000,000 years and a fraction of a second becomes meaningless. Scale becomes arbitrary. This allows for something remarkable. Through a mathematical transformation called a conformal rescaling, the infinite far future of one cosmic epoch can be mapped onto the Big Bang beginning of the next epoch. The end becomes the beginning. Imagine the universe expanding forever, becoming ever more dilute, ever colder, ever emptier. Now imagine rescaling that infinite expansion so it appears as a compact finite region. The transformation is mathematically valid in a universe of pure radiation because there's no mass to set an absolute scale. After this rescaling, what looked like infinite dilution becomes a hot, dense state. What looked like the heat death of an old universe becomes the Big Bang of a new one. The entire infinite future of one cycle is compressed into the initial instant of the next. This isn't just mathematical trickery, it has physical content. The geometry of space-time at the far future of one epoch matches the geometry at the Big Bang of the next. The transition is smooth. There's no singularity because the infinity of expansion in one epoch transforms into the apparent smallness of the Big Bang in the next. If this picture is correct, then our Big Bang was the rescaled infinite future of a previous universe. Before our time there was another time, before our space there was another space. What we think of as the beginning was actually a transition, a phase change from one cosmic epoch to another. Now you might ask what evidence could possibly support such a speculative idea. After all, we can't observe what happened before the Big Bang, or can we? The cosmic microwave background, the radiation left over from when the universe was 380,000 years old, carries information from earlier times. Tiny fluctuations in its temperature across the sky tell us about quantum fluctuations in the very early universe. These fluctuations seeded the galaxies we see today, but according to conformal cyclic cosmology, the cosmic microwave background should also carry signals from the previous cosmic epoch. Specifically, we should see circular patterns in the temperature map corresponding to collisions between supermassive black holes in the previous universe. When two giant black holes spiraled together and merged in the previous epoch, they released enormous energy in gravitational waves. This energy would create expanding spherical disturbances in the radiation. After the conformal transition into our epoch, these spheres would appear as circles in our cosmic microwave background. My collaborators and I have searched for these circles in the actual data from satellites that map the cosmic microwave background, and we found them. The patterns are there exactly where the theory predicts. The evidence is subtle. We're looking for faint circular patterns in temperature fluctuations that are already incredibly small, just millionths of a degree. The statistical analysis is complex and not everyone in the cosmology community is convinced yet. But multiple independent analyses have found an excess of concentric circles beyond what random chance would predict. These circles appear in pairs or even concentric sets, exactly as you'd expect from multiple black hole collisions in the previous epoch. The signal is weak but persistent across different datasets and different analysis methods. If this evidence holds up, if these circles are real imprints from a previous universe, then we're seeing across the boundary of what was supposed to be the beginning of time. We're detecting events that happened before the Big Bang. This completely changes the meaning of cosmic history. The 13.8 billion years since our Big Bang is not the age of time itself. It's just the duration of the current epoch. Before that was another epoch that lasted vastly longer, and before that another, potentially going back infinitely. Time didn't begin. Time has no beginning. The universe is eternal in both directions, cycling through endless phases of expansion, decay, and renewal. This also resolves one of the deepest mysteries in cosmology. The very early universe was extremely uniform. The cosmic microwave background has almost exactly the same temperature in all directions, varying by only 1 part in 100,000. How did regions of space that were never in contact with each other become so precisely coordinated? The standard answer is inflation, a period of exponential expansion in the first fraction of a second after the Big Bang. Inflation stretched a tiny causally connected region to enormous size, making the observable universe uniform because it all came from the same small patch. But inflation has its own problems. Why did it start? Why did it stop? What set the initial conditions for inflation? These questions push the mystery back without fully resolving it. Conformal cyclic cosmology offers a different answer. The uniformity of our universe was inherited from the previous epoch. The far future of the previous cycle was extremely smooth because everything had time to even out over hundreds of billions of years. That smoothness carried through the transition and became the uniform initial state of our epoch. No inflation needed. The fine-tuning of the early universe is explained by the coarse tuning of the late universe from the previous cycle. Time itself is the mechanism that creates uniformity. This also addresses the entropy problem. The Big Bang started in a state of remarkably low entropy for something so hot and dense. Entropy has been increasing ever since, driving the arrow of time, the directionality from past to future. But if the Big Bang was the beginning of time, why did it start with low entropy? That seems like an incredible coincidence. It's like finding a broken glass that spontaneously reassembles itself. Possible in principle, but absurdly unlikely. In conformal cyclic cosmology, the low entropy of the Big Bang is not coincidental. It's the result of entropy increase in the previous epoch, reaching a point where matter has all decayed away, and only radiation remains. Radiation has different entropy properties than matter. In a radiation-dominated universe approaching infinite expansion, there's a sense in which entropy resets. When the conformal transition occurs, creating a new Big Bang, that Big Bang starts with low entropy relative to its future evolution. Entropy increases again, eventually reaching a radiation-dominated state, which transitions into the next cycle. The pattern repeats eternally. Each cycle takes longer than the previous one because the expansion rate keeps accelerating. Our cycle might last 10 to the power of 100 years or more. The next cycle could last far longer still, but they all follow the same pattern. Big Bang, galaxy formation, star formation, black holes, decay, radiation, transition, repeat. Now let me address the obvious objection. If there were infinite past cycles, shouldn't we see more evidence of them? Shouldn't the sky be filled with signals from previous epochs? The answer is no, because information decays across the conformal boundary. Most of the detailed structure from previous epochs doesn't survive the transition. What does survive are specific large-scale features like the gravitational wave signatures from black hole mergers. Everything else, all the complexity and information generated during a cycle, gets washed out in the approach to pure radiation. This is actually necessary. If information accumulated from cycle to cycle, each new epoch would start more complex than the last. Eventually you'd have infinite complexity at the Big Bang, which makes no sense. Instead, there's an information bottleneck. Only certain types of signals cross from one epoch to the next. This allows for a kind of cosmic forgetting, a reset that makes each cycle genuinely new while still being causally connected to what came before. Some people find this picture depressing. If the universe cycles forever, if everything eventually decays and resets, does anything we do matter? Is it all ultimately futile? I don't see it that way. Each cycle is unique. The specific galaxies, stars, planets, and life forms that exist in our epoch will never exist again exactly the same way. The patterns are fresh each time, even if the underlying physics repeats. And meaning doesn't require permanence. Your life matters in this epoch, even if the epoch itself will one day transition into the next. The experiences you have, the consciousness you embody, the thoughts you think, these are real features of reality in this moment. Their eventual dissolution doesn't negate their current existence. In fact, I find the cyclic picture more satisfying than a universe with an absolute beginning and end. A universe that just starts for no reason, and either ends in heat death or big crunch, feels incomplete. It leaves too many questions unanswered. A cyclic universe is self-contained. It doesn't need an external cause or creator. It doesn't require fine-tuned initial conditions that appear out of nowhere. The conditions for each cycle emerge naturally from the previous cycle. The loop closes on itself. This doesn't prove the universe must be cyclic. It's possible the Big Bang really was a singular beginning and we're just clever primates trying to explain away the mystery. But the mathematics allows for cycles. The geometry permits it. And tentative evidence suggests it might be true. If conformal cyclic cosmology is correct, then we're living in one chapter of an infinite book. Our universe had a beginning in the sense that this particular epoch began 13.8 billion years ago. But time itself has no beginning. There were chapters before ours, and there will be chapters after. The story has no first page and no last page. It just continues, cycling through variations on cosmic themes, forever creating and destroying and creating again. I've spent years working out the mathematics of this picture and searching for observational signatures. The theory makes predictions. It's testable. We can look for specific patterns in the cosmic microwave background, in the distribution of galaxies, in the polarization of ancient light. Some of those predictions have been confirmed, others remain ambiguous. The community is still debating the evidence, but the conversation has shifted. We're no longer assuming the Big Bang was the beginning, we're asking what came before and whether we can detect it. That's progress, that's how science advances. We question assumptions. We follow mathematics into strange territory. We look for evidence in unexpected places. And sometimes we discover that what we thought was a wall was actually a door. What we thought was the beginning was actually the middle. What we thought was the edge of knowledge was just the beginning of understanding. The Big Bang wasn't the beginning. It was a transition. And that changes everything.